Hey, what's up guys? This is Prathamesh Patil from Team OCF. Today we will be going to be looking at a CPU cooler from Cooler Master. Now, as far as Cooler Master is concerned, they are really good at making cases, gaming peripherals, power supplies and CPU coolers obviously. So, this is a dual radiator CPU cooler all-in-one liquid cooling unit. So, I have this in my hand. It's a dual radiator 240M radiator, so that's what it specifies, Seidon 240M, whatever. So it has 20 FPIs, that is fins per inch, a kind of moderate density fins. The tubing is kind of flexible, not as flexible, but does the job on getting the block to the CPU. Excuse me. So it has a copper base plate and as a water block over it. That there's the pump, which is a DC pump, 1.8 watt DC pump, and the fans over it are the Cooler Master's extra flow fans. They spin at 2400 RPMs, has a static pressure of about 4.x mm H2O. These fans they apply a good static pressure, but to be honest, they are a bit loud. Cooler Master has to do something about it, or at least provide better fans with this unit. Anyways, that will be going to be covering in the conclusion part. So these are PWM fans, meaning you can control the speed of that fans. One thing Cooler Master has included is this rubber to mount the fans on the radiator. So basically what this does is just damp some of the vibrations to avoid a bit of noise. But anyways, now as far as testing is concerned, I have tested this liquid cooler against my own Noctua's NHD14. It was better to put a high-end air cooler against the AIOs that are available. So Seidon 240M versus Noctua's NHD14. So the comparison between these two, we'll have a look at some results. So what I used for testing, there's an FX8150 which I use. Then it was clocked at 4.2 GHz, 4.5 GHz and 4.7 GHz. These were the frequencies at which the coolers were tested. So first of all, I used the 4.2 GHz test at 1.25 volts, 4.5 GHz test at 1.3375 volts, 4.7 GHz at 1.368 volts. Now if you will see, I have used OCCT for stress testing the CPU. Now everyone will be going like OCCT is like very much highly stress testing tool and puts some unrealistic load on the CPU. So I know, but hey, we also know that that's the actual limit of the CPU coolers to which they are actually meant to work. Not exactly meant to work, but we do the testing on it anyways, so that the maximum capacity, or you could say the maximum threshold value, could be collected from them. Anyways, so the D14 versus Seidon 240M, the fans were at maximum speed at 2400 RPMs. Now again what I did, turn down the fans a bit until my ears couldn't hear it almost. So it was at 1700 RPM. The stock fans which we got with the Cooler Master Seidon 240M, we spin it down to 1700 RPM where we could barely hear it, so that we could also check out like what these fans are really capable of. And in order to test the radiator's power, what I did was I used my Side GT AP30s. Now those are the fans which have really very high static pressure, spins at a very high RPM. They spin at 4250 rpm, so that's a lot of airflow over there, so that we could really get some good results out of a moderate fin density radiators. That's what I did with the 240M, and it has a static pressure of 9.x mm H2O. So comparing like this kind of thing is unrealistic a bit, I know, but to be honest, I did this to check the maximum power on the radiator. Let's see what we got with the test results. So at 4.2 GHz, Noctua's NHD14 was at 52 degrees Celsius on 100% load OCCT running Lin pack. Seidon 240M with the maximum speed of the fans, stock fans, was at 49 degrees Celsius. Seidon 240M with 1700 rpm was at 53 degrees Celsius, and Seidon 240M with GT AP30's 4250 rpm fans was 46 degrees Celsius. Now bear in mind that whenever you look at those graphs, 4.2 GHz, 4.5 GHz and 4.7 GHz, the temperature was increased significantly as the voltage required was a bit higher than the previous value. So at the 4.5 GHz, D14 was at 67 degrees Celsius. Stock Seidon 240M with the stock fans at the maximum RPM was 59 degrees Celsius. Seidon 240M with 1700 RPM stock fans was at 63 degrees Celsius, and Seidon 240M with GT AP30s was at 55 degrees Celsius. Now you could see a barely good gap in the temperatures if you see the D14. Now obviously it's the high-end air cooler, not the liquid one, but that doesn't matter. What matters really is the surface area, and that really lived up to my expectations, and the jump was from 49 to 59 degrees Celsius for the Seidon 240M with the maximum speed of the stock fans. Then again at 4.7 GHz, the temps like spiked up on D14. It went from 67 degrees Celsius to 81 degrees Celsius. 67 was on 4.5, 4.7 GHz we got 81 degrees Celsius. Even I was thinking like something must have gone wrong or something, but no. To be honest, I tested it 3 times, but the results were same. It could be because of the OCCT, which puts some unrealistic load on it. That's the worst case scenario where you are never gonna hit those temperatures anyway. Anyways, moving on to the Seidon 240M with the stock fans spinning at maximum RPM. The temperatures went from 59 degrees Celsius at 4.5 GHz to 65 degrees Celsius at 4.7 GHz. Not a big gap, worked pretty well. Now it's a dual radiator, has a more surface area anyways, so it will perform better. Now the Seidon 240M with the 1700 rpm was at 63 degrees Celsius at 4.5 GHz and went up to 72 degrees Celsius at 4.7 GHz. So that gap is a bit more because the fan speeds were turned down anyways. So that's the temperature you are getting at 1700 rpms for the stock fans on Seidon 240M. The side GT fans on Seidon 240M was at 55 degrees Celsius on 4.5 GHz, and it did not crawl much, like it is at 61 degrees Celsius at 4.7 GHz, excuse me. So that's really holding the temperatures down. So you got to know the power of this radiator. This radiator is really good and can work really better with better fans. So that's it for the testing, and now we'll move on to the conclusion. Guys, now before moving on to the conclusion, I would like to tell you one thing. This time I have not done any unboxing, I have not done any picturizing of my rig, because I have already put up the snapshots on the link underneath on the main review. the written main review. There you can see all the pictures, you can also see the performance charts, the graphs, whatever you like to call it as. I've also put up the load and as well as the idle temperatures. So anyways, idle temperatures are not going to matter much because as you know, the D14 as well as Seidon 240M are really very good coolers, so that temperature won't really matter. That would be like very low anyways, so you won't be able to make out any difference. Anyways, now moving on to the conclusion. Seidon 240M is really a great AIO. So now before anybody starts like put it up against Kosus H100i and all, well, I don't have that. Otherwise I would love to put this against H100i or H100, whatever you like to call it as. And before that, again some people will be asking like, oh, Swiftech H220 is really better than this. But hey guys, Swiftech H20 is an expandable one, and that the purpose was for bridging the gap between the custom loops and the AIOs. So the purpose of Swiftech H220 is different, and Seidon 240M is a completely closed loop liquid cooling unit. So this cannot be compared to the Swiftech H220. Well, you can compare the Cooler Master's Iceberg against Swiftech H220. So that would be a valid comparison because both are meant to bridge the gap between custom loops and AIOs, meaning both are expandable. Both have really very good pumps. Seidon is not meant for that. Anyways, I will give this Seidon 240M 8.5 on 10. It's a recommended one. Really good design, really good performance. The radiator and pump is really good. Pump is it really satisfies the need of a single block and one radiator, a 240M radiator. So no need for any extra power. Anyways, the radiator really performs well on better fans as well, but I would like to focus on the negative points as well. The only negative point which I found out was the fans aren't that good. So Cooler Master, if you are listening to this, please replace these fans or at least provide better fans with this all-in-one liquid cooling unit. Now bear in mind, the performance of these fans isn't really bad. They perform really well, but to be honest, these are very loud, and I am a kind of silent freak who don't like much of noise. So bear in mind that, please. You could just replace those fans with some other things when you launch a different kind of cooler. I think Neptune is coming up, Neptune 140 and 280, I think. Yeah, so do better with that. Anyways, so that's the suggestion for Cooler Master. Guys, I forgot to mention two things. The tests were done at 21 degrees Celsius ambient, and the fan configuration which I used was in the pull configuration. So no matter what you do, push or pull, both are going to result the same. You people already might be knowing that. Anyways, so apart from that, the installation is pretty easy, and definitely I'll recommend you to buy this if you are upgrading from an air cooler to a AIO or something like that. If you want the expandable ones, well, I haven't tested it yet, so I'll be making a future review on Cooler Master Iceberg or Swiftech H220 or whatnot. So we'll probably have a look at that after this. But if you are going to upgrade to any AIO, closed loop AIO, so I would definitely take into consideration the Cooler Master's Seidon 240M. Anyways, I'm going to keep this video short and sweet. not like the previous one which was too long. Many guys out there told me, so now I have to leave. This is Prathamesh Patil once again from team OCF. Highly recommend you to buy Seidon 240M. Signing off, out.